Well, my name's Amanda, and I'm from the Center for Teacher Leadership.
And I'm Nicole Harris, and I'm a 7th grade teacher at Lansdowne Elementary School.
And today we're going to be talking about deepening some mathematical understanding with the use of number lines.
So,
our learning intentions are to increase our confidence and our ability to integrate the use of one or more of the selected number line models that you'll get today into your curriculum. And your success criteria is incorporating the use of them in your lesson plans.
and we just wanted to show you this quick little comic here that we promise this will be applicable to your teaching situation, because a lot of times we have instruction and we have to be able to know if it isn't really meeting our needs as classroom teachers. So we promise this you will use later in your teaching life.
Okay, so I always like to give you strategies that you can use in the classroom. Get you up, get your blood flowing a little bit. So I gave you a card, and what we're going to do is create a human number line. And we're going to try to do this silently. And you have your number. Nobody else can see your number. Your number can be positive or negative. It could be a fraction. It could be...
So we wanted to share with you a little bit of data about why this session is applicable to your situation in our school. So according to Lansdowne's information, these are some of the areas where our students in 3rd grade have struggled on the SOLs for a trending 3-year time period. So rounding, computation with fractions, comparing fractions, elapsed time, estimation, and any sort of representation of fractions, we have been struggling in those areas. Especially the last one, representing fractions, we have actually scored 10% lower than the city average. So even though our math scores as a building are going up, these are the areas where we tend to struggle. So what one type of manipulative can we use to teach all of these struggling areas? You can fit. It would be number lines. That's why you're here today. We want to give you a little bit more specific data as well. So when we look at our students, and we polled our 3rd grade students this year, and the orange color represents the total population of 3rd graders. 47% of our students know what an open number line is. Only that's less than half, obviously. 22% of our 3rd graders know what a closed number line is, and 45% know what a beaded number line is. The reasoning that those words are so important is because a lot of times that is the verbiage that will be on the SOLs, as well as if they haven't been exposed to them, they don't know how to use them. And then when we asked them what they could actually use the number lines for, our number one answer was we can use it for math. What we can do with it, a lot of students really weren't sure, but the top 3 answers after math were we can use it for addition, we can use it for subtraction, and for rounding. Estimation really didn't come up, fractions didn't come up, multiples didn't come up, so a lot of things that we really need to be working on with our students. As far as 2nd grade teachers being here, we know that you're the foundation for 3rd grade. That's why we thought that it was important to share this with you so that as well you would know how to integrate to build the foundation for 3rd grade. So obviously it means we need more exposure with our students.
Okay, and so I'll let you take a minute to read a little bit of the research behind integrating the manipulatives in math as much as possible, especially in the lower grades. This goes all the way for 5th grade, as a matter of fact. So the evidence indicates that, in short, that manipulatives can provide valuable support for students learning when teachers interact over time. It builds a link between the object, the symbol, and the mathematical representation. So what is a number line, a manipulative, and a thinking tool? It's a visual representation, and each mark represents a mathematical value. The focus is on the interval space between the dots or lines. You're going up 1. That's your, 1 inch is how I always told my students. You're going up 2. So we'll take that and go to the next one and look at possible.
So the one type of number line that we want to talk about first, so we're basically going to show you the 3 models of number lines, and then we're going to show you how you can use them each in your classroom and do some other activities so you get some hands-on experience. So we won't just be talking the whole time for you. This is basically a picture of an open number line. It is a line that has no predetermined values on it. The students can divide it as they see fit. So that can turn into a from 5 to 100 number line, or it can turn into a 0 through 10, or it can become fractional pieces. So for example, this is a objective for 3rd grade. If you had to round 323 to the nearest 10, a student who would be using an open number line would first start by drawing the line. They would set their own determined values. So we would hope that because they know to round to 10, they would pick 320 and 330. They would put the 325 mark in the center and figure out where their number goes. So 323 would go right around there. Obviously, it's not predetermined for them, the spacing, so it really is a guesstimation of if this is the middle, then 323 is about in this area. And from here, they would look, 320 is this space away, and 330 is a much larger space. Therefore, we would round our answer to 320. Any questions about that one? Yay!
I do that every day on calendar.
Oh, good. Perfect.
And so this is a closed number line. And once you put a second point, it identifies it from an open to a closed number line. So we're going to model 5 times 4 in the number line. So they would start at 0, and they would count 5 4 times to get to 20. So they're going to see that on their 3rd grade SOL.
Yep.
4th grade and 5th grade SOL, as a matter of fact.
It's very hard for them.
It is. It is. Sometimes I turn it into groups, but it's the interval spaces in between.
Is the beaded number line. This is a kinesthetic resource. Obviously, it only has 100 beads on it, but that does not mean it's limited to just 100 for its value. It's set in groups of 10, so each color change is represented by 10. I always tell my kids that the circle at the end represents the 0. Obviously, if you're going to be starting at a different number, though, it wouldn't represent 0. But it's great for a remediation tool. It's great for extension. So if you were having, our example here is skip count by 10 starting at 120, even though there are 120 beads on it, a child who may need the extra support would say, okay, 120, 130, 140, 150, 160, and so forth until they get to the end. Once they go to the end, though, they don't have to be finished. They can always start over and continue with that.
So we want to watch for some misconceptions that our students have. What misconception might they have with this number line? What sum is represented on the number line? Or what misconceptions have you seen your students?
They might just think it's 66. Just look at
They might think the answer is 66 and think that it landed on 66. Perfect. A common answer for this model is 13. And why do you think that is?
Counting the dots, right?
Yeah, they're counting the dots instead of the intervals in between. And that's where that beaded number line can really come in and help.
Does anyone have any questions about the 3 types overall? The one thing that you can always remember is that once it starts as an open number line, as soon as they set their 2 points on it, it becomes a closed number line. So really, you can use that as just, trying to show them, like, look, it doesn't stay open forever. As soon as you put numbers on it, it turns into that closed number line. A lot of times, we find out that upper grades don't want to use the beaded number line because they think that the kids don't need that. It really is helpful, though, as a remediation tool for your kids who may not be able to count by tens, or they just don't understand the concepts. And we're going to show you some uses with how you can actually put it into your curriculum. So you're sitting in groups by grade level. So what we want you to do is 3rd grade, we're going to give you beaded number lines. And we would like you to show how you could solve 93 minus 56 using a beaded number line. It is a problem that involves regrouping, and a lot of times that's something that students struggle with. So because you're using a manipulative, they won't have that struggle of having to regroup. Second grade, you have some construction paper and markers at your table, and if you could use it showing an open or a closed number line, that would be fantastic.
All right, so we're going to have somebody share out how she answered the
All
question.
right, now I gotta think how I did it. All right, so we said that this was 100, right? So I counted by tens, 10. It's hard to do when I'm standing up. It's easier to do laying down. 10, 20, 30, 40, 50, 60, 70, 80. That's how I make kids do it. 90, 91, 92, 93. That's how I would have my kids do it. So they would have them show me the 93. And then they're going back 56, so I would tell them to kind of really hold these three and then just count back by 50. So 10, 20, 30, 40, 50. And then I would have them add the other three, so that's their 56. And that's what they're getting subtracted or taken away. And then what is left is the difference. So 10, 20, 30, 31, 50, 45.
And then second grade was, they had a really good conversation about their open number line, which obviously as soon as they added their points, it turned into a closed number line. Susan, did you want to share what you did?
Sure. We decided to use the concept of counting by 10. So we started at 93, and then we counted backwards, which is a skill that we're actually working on with the kids right now, counting backwards by 10 when it's not on an even 10, and they are struggling a little bit with that. So this might be a great, just build a number line that shows counting backwards, like not a subtraction problem, but build a number line.
Right.
So 93, back to 83, 73, 63, 53, 43, so we could get 10, 20, 30, 40, 50. And at that point, now they need to do the 6, so we just did 6 single hops. 41, 42, 41, 40, 39, 38, 37. And then having them write that this is the 10s and this is the 1s.
I like how you talked about having them build it and how they're writing. These are the 10s, these are the 1s. So they're getting better understanding of numbers. Explain that to you.
So we wanted you to see really how this can build from kindergarten the whole way through 5th grade. That way we know right now it's only 2nd and 3rd grade teachers, but so that special education teachers, or if you have a student who's coming from another system, they may have had different objectives than us, and how it just builds throughout the grade. So if we start introducing it younger, what you can expect, and then as well 3rd grade teachers where it will go in 4th grade. So there's a white envelope at your table, and if you could work together, there are a set of objectives and then a number line that represents that objective. So if you could just take a few minutes and sort that with your team. And then we will talk about it in a few seconds. Okay, so we want to make sure that you match them correctly. And the purpose of this is not so that we know if you can match cards, but rather so that you can see how kindergarten can start using it, and then it can progress the whole way through 5th grade. So if we take a look, and I know it's small for you, but the kindergarten objective would be to identify the number that's one more or one less. And I did hear 2nd grade teachers were still saying that that is actually still something that 2nd grade students struggle with, is identifying what's one more than the number, what's one less than the number, especially once it gets over the 100 mark, because in 1st grade they only learn to 99. So when we get to 123, they still struggle with what comes next. So that would just be the closed number line that has a 0 through 10 on it, and then they mark the number that's one more with an X and one less. Moving into 1st grade, counting by 1s, 2s, 5s, and 10s to 100 and counting back. You can see in the model it's a closed number line, and teaching the kids to go through the process of actually drawing it out, starting at a certain point and counting backwards on the number line would be great. 2nd grade, it's another rounding example. Find the number, round it to the nearest 10. I did hear the 3rd grade teachers were talking about that as well, saying sometimes it's hard for the students to understand their two choices, though. That's really where the beaded number line could come in. If you started at just looking at the number 100, okay, here's 60, here's 70. Look at the beads. What are your two choices? And I shared with them that you can use clothespins as well to mark where the numbers are on the beaded number line so that they don't have that difficulty of losing their place or, oh, now the beads slid together. They can just mark their spot and then look at it as a better visual representation. Third grade goes into rounding those numbers to the nearest 10, 100, or 1,000. And again, just making sure that they create that number line and picking the appropriate marks on it. Fourth grade moves into comparing whole numbers using the symbol, so the greater than, less than, or equal to symbol. But again, finding the marks on a number line, when it's not provided, a lot of kids need that visual. Asking them just to do it mentally, some of them just can't do it. They need to see it and need to see the distance, and really that's where the number line comes in, because you're looking at the spacing, not necessarily just the numbers. And then fifth grade would be rounding decimals through thousands to the nearest whole number as well. Does anyone have any aha moments or any questions about any of the models? Okay, then we're just going to move right along.
All right, so our intentions for today were to successfully integrate the 3 number lines into our curriculum. And so with the knowledge of what you have coming next for your students' objectives, we would like to do a placemat consensus with our team. So I'm sure you guys have done one of these before where you put at the center of your team, you have 4 people, and you start writing down some strategies that you have. How can I integrate the use of these number lines in my curriculum when I go back? And when you're done writing down your own strategies, you can discuss them with your team and come up together with a theme.
Is a little support sheet. It has 6 different visual representations, because the one group was asking, well, what would that look like if the number model was given to the students rather than them creating it. So there's 6 different representations. It does go into fractions and mixed numbers and elapsed time. I know second grade we don't do elapsed time, but just showing them how to put time on a number grid will help, or a number line will help out third grade. Their probability is on it. Everything is on here, and it just starts with 6 different ways you can start integrating as you start your lessons.
It's a great resource to tuck into your lesson plan book or your... The next moves, we're going to meet again on October 29th. And before we meet again for final professional learning on it, we want to let you know that we're here to serve and support you. If you need anything at all, let us know. We can come in and observe. We can model for you. We can take a group for you. We'd like you to take some of the strategies with you into your classroom so that when we get back together on the 29th, we can reflect on what went well, or, okay, I used this, but it didn't go so good. I think my kids are more confused now. What can we do to support you there? Did you have any questions?